So feldspar group, no? Feldspar group, we term it is a group. That means this group will consist some minerals, okay, which are having more or less same physical properties. So it will include the rocks, it will includes the minerals having different chemical composition, but will have more or less same physical properties. Okay, so the minerals which are having more or less same physical properties with a certain variation in their chemical composition these minerals are grouped and they will be named they are named as the feldspar mineral. Okay, so feldspar, the minerals in the feldspar groups are very prominent rock forming minerals there. Okay, the composition of this feldspar, you have a number of minerals in the group. The composition of major feldspar can be expressed in terms of a system. What is the system? The system is the most of the majority of the feldspar can be explained with the N member as orthoclase, albite and anorthite. So orthoclase, it has this potassium aluminum silicate, albite sodium aluminum silicate, anorthite calcium aluminum silicate. So these are the silicate mineral. You have the SiO tetrahedron, no? Then you have the potassium aluminum sodium calcium. These are the cations. They will be fit into the SiO tetrahedra. Okay, so these members, the feldspar which lie between this orthoclase and albite are termed as alkali feldspar, and the members between the albite and anorthite, they will be known as plagioclase feldspar. So we are having two groups in the feldspar, alkali feldspars and plagioclase feldspar. So alkali feldspar are between the series potassium aluminum and sodium aluminum. So these minerals in this side of this triangle is called alkali feldspar, and these minerals are called plagioclase feldspar. So what we express that the composition of the feldspar can be shown by a triangular diagram based on their chemical composition, and the apex will be, this is the potassium aluminum silicate, this is orthoclase, this is albite, and here we will have anorthite. Okay, so we can explain the chemical composition of most of the feldspar by this ternary diagram. And in the ternary diagram, okay, in the left side of this diagram are alkali feldspar. They are the solute solution between the orthoclase and albite. Okay, so we have the member, okay, microcline, cyanidine, anorthoclase. Okay, then in the base of this triangle, the members can be explained or expressed by the solute solution series between the albite and anorthite, and they are termed as plagioclase feldspar. Okay, they are termed as plagioclase feldspar. So this feldspar, we have the composition between potassium aluminum silicate, sodium aluminum silicate and calcium aluminum silicate. So they are the silicate minerals. Okay, so as you see, the member of the groups in the feldspar group, you have microcline, cyanidine, anorthoclase. Okay, then you have albite, oligoclase, andesine, labradorite, bitonite, anorthite. So all these mineral, okay, different mineral, they are having more or less same physical properties, but a different chemical composition lie between these three N member, okay, series. You can you see alkali feldspar. This the feldspar is like that. This is form is the tabular. You can tell it. Okay, so this is the orthoclase feldspar. Okay, this is the plagioclase feldspar. The color you see, this color is light in color, this is reddish in color. Okay, this plagioclase is between sodium and potassium, sorry, calcium, and here the alkali feldspar is between potassium and sodium. Okay, these feldspar are tetrasilicates. So in which, as I discussed, the SiO4 tetrahedron is combined with the cations like potassium, sodium, calcium, and aluminum. These will be our cations, and this is anions. So this is will be in fit combined with this cations. Okay, now whether our mineral will be stable or unstable, as we discussed, based on how the cations and anions are fit each other. So physical properties, when we discuss the physical properties, all the minerals of this group. Okay, they are mainly, crystal system are mainly monoclinic and triclinic. Okay, so one axis may be inclined or all the three axes may be inclined. So their form are tabular. Okay, we discussed the cleavage, perfect two directional. You will have plane of weakness in the mineral in a two direction which are prominent. Fracture uneven mainly. Sometimes you have concave, but uneven is that surface is rough and irregular. Color white, gray, pink, green, red. As we just check in our figure, you may have mainly the pink color and the white color and some of the gray color. Okay. Streak, definitely in the colored varieties you will have white, but otherwise it is colorless. Okay, so mainly we will have white. Luster vitreous. Okay, hardness 6 to 6.5. Okay, specific gravity is low within this range. Okay, these are the physical. Why we are discussing this? Because feldspar are most prominent rock forming mineral. So you will have the rocks which are composed of the feldspar. Then definitely when you have taken this rock as a building stone or building materials, okay, road metal, definitely this strength properties and other properties, it depends upon the properties of the minerals. So you should know what is the hardness, what will be the specific gravity. Okay, then whether it has cleavage or not. Cleavage is generally in the many of the feldspar, cleavage are absent, then it will be good. Okay, cleavage is classification, two groups. Okay, as we discussed, alkali feldspar, okay, and plagioclase feldspar. Alkali feldspar we have autoclase. Okay, the crystal system is monoclinic, and this is potassium aluminum silicate. Okay, then cyanidine, it is also monoclinic. You see why we are having the different name. It will having potassium and sodium. Potassium will be more, sodium will be less. Okay, as we go here, here you see this is say autoclase. Okay, this is autoclase composed of potassium aluminum silicate. Now if you move from this point to this point, what will happen? You will have the mineral, the potassium will be decreasing, sodium will be increasing. So here you will have the both potassium and sodium, because this is the sodium element. Here in autoclase you will have more sodium. Okay, more sodium here and less potassium, and here you have all the minerals are sodium. You will don't have any potassium here, albite. Okay, here you will have the mineral is rich will be sodium. So as you move from here to here in this left side, you will see the mineral will be having potassium rich. As you move in this direction, the mineral will be having potassium, sodium, and potassium will be decreasing, sodium will be increasing. Ultimately you have sodium rich. Now if you move in this direction, the plagioclase feldspar, you have this is you have more sodium and less calcium. Okay, as you move in this direction, your sodium will be decreasing and calcium will be increasing. Okay. So you see, this is you have potassium and sodium. Okay. Then microcline, again it is potassium aluminum. Microcline and orthoclase, they are having same chemical composition, but their physical properties are different. One is monoclinic, another is triclinic, so that is the name is different. Orthoclase generally you will have light in color, white in color. Microcline is pink in color. Okay, flesh red. Orthoclase, sodium, potassium. Okay, again sodium, potassium. So what it is? It is here potassium sodium means potassium is more, sodium is less. Here sodium potassium means sodium is more, potassium is less. Got it? Am I audible?
Yes, sir.
Okay. So you got it? Okay, this is here potassium is more, sodium is less. Here sodium is more, potassium is less. Okay. Now plagioclase feldspar, they are triclinic in a crystal system. They are from the isomorphous series of 6 feldspar. Isomorphous series means their forms are same but chemical compositions are different. In quartz, what we had in quartz, we discussed that they are the polymorphism of SiO2. That means their forms are different, chemical compositions is same. Okay, SiO2 is their chemical composition, but their forms were different for different mineral. Okay, then what we got in this tridymite, cristobalite, okay, quartz, all this we got. They are all this having the same chemical composition, but their forms were different. Here what we have, their forms are more or less same, but their chemical compositions are different. You see albite. So albite you have, you see albite, what is the chemical composition? The chemical composition of albite were NaLO8. Okay, so if we move here, we can write it is very slow. Too slow, huh? So what we got? So we have albite, huh? Albite. What is the composition? Sodium, aluminum. Sorry. Sodium, aluminum, Si3O8. Okay. This is one mineral. Then we have another mineral. We call them anorthite. Okay. So CaAl2Si2O8. Okay. Oh, okay. These are Si2O8, huh? Okay. So like that. So NaAl SiT, this is albite, this is anorthite. Now these are the two N member. Okay, two N member in this here. No, here we have these two N member. Okay, here we have albite, here we have anorthite. Now in between you have, so what, when we call it albite, albite in the diagram, if you go to this series, you see here, you see coming slow. Here you see, if you say this is albite, no, this is say 0, 10, 30, 50, 70, 90, 100. ठीक है sir? So 0 for calcium. For calcium, if you go here, the calcium will be 0 here, calcium will be 10 here, 30, 50, 70, 90, 100. Okay. Now sodium, it will be 100 here, then 90, 70, 50, 30, 10, and here sodium will be 0. You got it? Buji paisa?
Yes, sir.
Okay, okay. Now you see, all this mineral can be explained as the solid solution series between two N members, sodium and calcium. We call it albite and anorthoclase. Now any of this member, if we discuss the oligoclase, this is the member, you will see. So here if we discuss the albite, albite, then what happen? Albite will be from, that means 100 to 90, and anorthite here will be 0 to 10.
Sir, we couldn't hear you that line, sir.
Okay, you see, this is the area of albite. Okay, this is albite. Okay, now as I discussed that the albite will be here 100. Okay, there will be 90, it is 70, 50, 30, 10. As you go in this direction, albite will be decreasing, anorthite will be increasing. Okay, and if you move in this direction, that albite will be increasing, anorthite will be decreasing. Here albite, you see, this is the albite mineral. Here you see the composition sodium will be more. Okay, albite, we call it albite, say it will from 100 to 90. This is 10. Okay, albite from 100 to 90, and anorthite will be from 0 to 10. Is it clear? Okay. Again I will move to here. Okay. Now what I will do, I will draw a triangle. Okay. So here it is. This is albite. Okay. And here this is anorthite. Okay. Now you see here albite will be 100. Here anorthite will be 100. Okay. Now suppose this is 10, this is 30. So sorry, 10, 30, 50, 70, 90. Okay. So this is say 100 for albite, 90 for albite, 70 for albite, 50 for albite, 30 for albite, 10 for albite, 0 for albite. And here you see anotite 100, here 90 here, 70 here, 50 here, 30 here, 10 here and 0 here. Clear? Okay. Oh shit. Okay. Now any of the mineral which is lying in this area, they will be rich in albite and less in anotite. Okay. As you move in this direction, your albite will be decreasing and anotite will be increasing. Okay. So it is clear now?
Yes, sir.
Okay, then if we move to here, then why I am discussing this point again and again. Okay, so we will write here. So any of the point here. So this is albite. This is 100 for albite, 0 for albite here. Okay, 0 for albite here. Here 100 for anotite and 0 for albite. That means calcium is 100%, sodium is 0%. Okay, like that. Now here you see this is a mineral oligoclase. Okay, try to understand the thing. Oligoclase. What will be the composition of the oligoclase now? This is for sodium albite. This is 90. This is 100. This is 100. This is 90. This is 70. Now, when you have oligoclase, the oligoclase range from albite 90 to 70. When it is 90 for albite, this is 10 for anotite. And when it is 70 for albite, this is 30 for anotite. Okay, so there should be 100 in between them. You see now, albite, this is AB means albite 100 to 90, anotite 0 to 10. Okay, so you have sodium, aluminum silicate. So sodium will be more. Now oligoclase, you see albite. Now this is the solid solution series between what? Sodium and potassium, albite and anotite. Okay, as you discussed, albite will be sodium, anotite will be calcium. Solid solution. Now, second mineral, it will having composition of both sodium and calcium. Sodium will be more, calcium will be less. Now, what will be the sodium range? Between 90 to 70 and calcium range between 10 to 30. So, if you add, then it become 100 again. 10 plus 90, 100. 70 plus 30, 100. Now, next mineral you see, the albite. That means sodium is decreasing, anotite is increasing. Now sodium become, albite becomes 70 to 50, anotite become 30 to 50. So this is in between sodium aluminum silicate to calcium aluminum silicate. Okay. Now you see albite become 50 to 30, anotite become 50 to 70. Now you see calcium coming fast. Calcium will be more, sodium will be less. Okay. Here it is in between balance type. Here now slowly calcium is increasing. Now next is the bitonite mineral. You see this composition is, sorry, this is again wrong here. Okay, this is again calcium, sodium, aluminum silicate. This should be correct. Okay, Si is not there. Okay, calcium will be coming fast, then it will be sodium, then aluminum. Okay, now you see that albite is slowly decreasing, anotite is increasing. Now you see the anotite, albite is 0 to 10, and that means you don't have sodium here, and all the mineral calcium, aluminum. So anotite will be 90 to 30. So this is the how we can discuss a solid solution series in percentage wise between the two n member. Okay, these are all the mineral, this oligoclase, andesite, labradorite, bitonite. All these minerals are the solid solution series between albite and anorthite. Now you have to explain it by the how much albite will be there and how much anorthite will be there. As you move from left side to right side of the triangle, this plesiocal feldspar you have from left to right, albite will be decreasing towards the right, anorthite will be increasing. Okay, is it clear now? Kiba confusion আছে যদি খুদা any confusion regarding here, regarding the composition of the solid solution? Are you hearing me or not?
Yes, sir.
Any, you got the points, no? What I want to explain actually the solid solution between
Yes, sir.
some others may speak. Anyone?
Yes, sir.
বুজি পাইছা না কথাটো বুজি পাইছা না? Yeah, just proactive man, you just tell any problem or like that, no? ঠিক আছে? Now the occurrences.
Hi, sir.
So feldspar is the name of a large group of rock forming silicate mineral that make up the 40% of the earth crust. Very important. In the earth crust, whatever the rocks you will get, out of these 50% of these rocks are made up of the minerals feldspar. Okay, so feldspar is very important to understand some of the strength of the metals, you call it rock. Then you have to understand the properties of the mineral of those. So they are found in all the type of rock: igneous, metamorphic, and sedimentary rocks. Okay, they can be used as ceramics, glass, tableware, okay, other electric porcelain, okay, false teeth, they are used. But we will restrict ourselves to study those rocks or study this mineral as a rock forming mineral and how it contributes to the strength of a particular rock by seeing its properties. Okay, so in a nutshell you can discuss the feldspars are very important rock forming mineral, number one point. Second point is that the majority of they are the group of minerals which are having more or less same physical properties with a certain variation in their chemical composition. So the majority of the feldspar, their composition can be explained by the 3 n member. They are orthoclase, albite, and anorthite. Orthoclase is potassium aluminum silicate, albite is sodium aluminum silicate, and anorthite is calcium aluminum silicate. Now the member between orthoclase and albite, they are called alkali feldspar. Alkali feldspar means K feldspar, rich in potassium. Okay, and the members between albite and anorthite are called plesioklase feldspar. Okay, and they are hard mineral. The hardness is 6 to 6.5. They are specifically graded low. Some of the minerals are white, some are minerals may be flesh red. Okay, and they show sometimes cleavage, but those minerals which are not showing cleavage will be better as a rock forming minerals for the strength perspectives. Okay, and they occur in almost all kind of rock like sedimentary, igneous, and metamorphic rocks. They are the important rock forming mineral. Okay, next pyroxene. So quartz and feldspar, they are light color mineral. If you go to the composition, you see the quartz is composed of SiO2. Okay, silicon oxide. They are light in color. And when you check the composition of the feldspar, what you have, the composition of feldspar are mainly potassium, sodium, and calcium. Okay, calcium, sodium, and potassium, they are light color mineral, these minerals, because of the composition. Now when we move to this pyroxene group, you will see these minerals are dark in color. Okay, it is also important rock forming minerals. Okay, they are dark color. Okay, say dark color igneous and metamorphic, they commonly occur. So because of the dark color of the rock is presence of pyroxene in a rock, if you have some light color mineral, then you can first you can identify that they might be quartz or feldspar. If you have dark color mineral, then this mineral may be other mineral, pyroxene, mica, amphibole, like that. The pyroxene are dark color mineral. They are mainly enriched in iron and magnesium. Okay, calcium, magnesium, iron, silicate, they are. Okay, mainly iron and magnesium. They are showing single chain silicate structure. We discussed what is single chain, double chain earlier, no? So this is single chain. It can be classified into orthopyroxene. Means orthopyroxenes mean their crystal system is orthorhombic, and clinopyroxene, okay, maybe the triclinic and monoclinic, okay, based on their internal. All these, whether the crystal system is based on the atomic structure of the mineral. Okay, so orthopyroxene, this is enstatite. You see the composition is magnesium silicate, hyperstin, magnesium and iron silicate. So these are important. The composition is important. This will give you the dark color. So any rocks which are having dark color may be present magnesium and iron. If it is light color, it means the rocks in the minerals are mainly composed of sodium, calcium or potassium. Okay, then clinopyroxene, you see calcium, sodium, magnesium, iron, mainly magnesium. Okay, this is the name. You can remember all this formula here. Then diopside, you see again calcium, magnesium, Edenbergite, calcium, iron. Okay, so if you go, you will have the mainly iron and magnesium. Okay, so you see that color. These are single chain silicate in which Si4 tetrahedron are combined with calcium and magnesium and iron cations. These are the cations and this is the anions. It will be combined. This SiO4 will be combined with this calcium, magnesium, iron. So you just remember the things what I have discussed, whether how the tetrahedron is fit in the cation. We discussed in the earlier. So this is the most important or most common pyroxene name augite. Okay, they are calcium, magnesium and iron. So that is why the color is dark because of the presence of magnesium and iron. These are called mafic mineral, ferromagnesium mineral, iron and magnesium. These are called, augite is called ferromagnesium mineral because of enriched in iron and magnesium, and there are some certain amount of calcium. So this is the dark color mineral. So single chain, no silicate, double chain. They are mainly single chain. So these are the major pyroxene, no, enstatite, orthopyroxene. These are their chemical composition. Okay, different type of calcium. Different type of pyroxene. If you go through this, their formula, chemical composition, you see they are mainly rich in magnesium and iron and calcium. Okay. Physical properties, orthorhombic and monoclinic. So that is why if it is orthorhombic, we call them this is called their hyperstins are there. Okay, and orthopyroxene, if we call if it is the monoclinic, we call them clinopyroxene. Okay, their lasers are glassy or metallic, shining. So you see their laser, how what is looking like is shining is like a metal, na? Here you can see shining is like a metal. So it is laser is glassy or are black mainly. Streak may be light green, light brown, or white based on the different composition. Hardness 5 to 6.5. Again, it is a hard mineral again. Okay. Cleavage. Sometimes you have cleavage that are at nearly at 90 degree. So it is not like that you will get the cleavage in all the mineral of this group. This is a common physical properties. It is not like all the mineral of pyroxene you will have cleavage. Many of the mineral you may not be having cleavage. Okay, but there are some possibilities. Fracture uneven. Next, after the pyroxene, we will discuss the amphibole groups. Okay, this is also a dark color mineral. These are okay, closely related to the pyroxene. It shows double chain silicate structure. Okay, again rich in calcium, magnesium, iron oxide, and manganese, sodium, potassium, and this hydrogen. An important group of rock forming mineral in igneous and metamorphic rock like the pyroxene. If you go to any of the igneous rock like granite, if you check the granite, you will have quartz, then you will have feldspar, then you will have some dark color mineral. These dark color minerals are composed of some of the are amphibole, some are mica, some are pyroxene sometimes. Okay. The pyroxene and are mainly found in basic rock. Okay, that in the granite you will not get the pyroxene. We will discuss in the you should remember all this point. We will discuss next time when we will discuss the rock. I will again refer to all this point again and again why we are having not. So that is why I am put some stress here that these are the minerals. You will have a rock will be having dark color because of the presence of this mineral. If you have a rock composed of light color mineral like quartz and feldspar, you may not have pyroxene, but you may have some amount of amphibole. Okay. So again, orthorhombic and monoclinic. Okay. The example is hornblende is important rock forming important minerals of the amphibole groups. Tremolite, actinolite. Okay. You see the color. These are double chain silicate. Double chain silicate in which Si4 tetrahedron are combined with potassium, sodium, calcium, magnesium, iron. So cations are all this and OH. So hornblende is the most common amphibole mineral. Color is like. Okay, this is hornblende where you have silicate Si4 tetrahedra with this. These are the common elements. And asbestos, this color is fibrous. So these are fiber. These are fiber. Okay. So this is having this again this mineral calcium, magnesium, sodium element. So this if you say both the minerals are having same composition more or less. Now one is dark in color, one is light in color. It is because which elements are more. If it is sodium, aluminum, calcium are more, then it will be light in color. If you have magnesium and iron are more, then it will be having dark in color. But more or less, they are having all the elements. Okay? Which is more? It's give you that color. Physical properties, prismatic, acicular, na? So fibrous just now, acicular, needle-like, na? Prismatic. Then hardness is 5 to 6 again. Cleavage, sometimes you have two directional at 56 and 124 degree. Okay, that means you go in the rock. So wait here sometimes. This is the problem. Okay. Okay. Now I have a mineral like this. Okay, we have a mineral like this. Now what is cleavage? We discuss again in the earlier classes also. Suppose this is the mineral in amphibole. Okay. Now what they say that the cleavage may be like that. Two direction. Okay. So okay. So if it is 56 degree, it is 124 degree. If it is 56 degree, it is 124. Okay. So like that. So one set cleavage, plane of weakness like that, and another set like that. Okay, you will have. So if the mineral is consider the cleavage like this, then the strength will definitely will be less. So but it is not like the all the mineral having the cleavage, but most of the minerals they are having cleavage in this system. So this is acute angle, this is obtuse angle. It is 56, this is 124. Okay, so this is the cleavage orientation. So this is the cleavage orientation. Okay, 56 and 124 degree they will be oriented. Specific gravity 2.9 to 3.6. Dark green, dark brown color. Luxury vitreous, the colorless or white. Okay, then this is generally opaque mineral. Okay, occurrence found in the igneous rock mainly. Then mica group is one of the important rock forming mineral. They form the sheath like structure. I discussed earlier also during the cleavage. No? They are having sheaths because of the mica. Generally they have one set of basal cleavage. They have the parallel cleavage along the base which form the sheath structure of the mica. So they can be split into very thin sheet along one direction along the base. We call it them flakes. No? So like that. So they are mainly rich in aluminum and magnesium. As it is rich in magnesium, they are having dark color. Aluminum give them certain time light in color. Okay. 4% of the earth crust approximately. It's so basal cleavage along the base. I discussed in the earlier, and I don't need not to discuss. I think I need not to discuss again this point because during the cleavage, I discussed details about the basal cleavage. So classification like mica, they are muscovite. You see potassium aluminum silicate, no? Potassium mica. So they will be light in color as they are composed of potassium. Okay, this is paragonate sodium aluminum. Soda mica, sodium is there. Okay, lepidolite, potassium aluminum, lithium mica. Okay, you have lithium here. So these are light in color. Muscovite, it is common mineral you have in the rock. Then dark mica, biotite is important. One of the common. This you have magnesium and iron. Now, how you identify the mineral in this rock? Suppose if a rock you have very shiny flakes, okay, then if it is flakes type of shining mineral, then you say this is a mica. Now if this mica is light in color, now we can commonly refer to it muscovite. Okay, light in color, we commonly refer to it muscovite. Now if these flakes are dark in color, we commonly refer to it biotite. Okay, these are some of the member of the mica. So these are the chemical composition. No? So crystal system, they are monoclinic. Hardness is very less, 2 to 3. So the rock, which is mainly composed of mica, they will be weak rock. Okay, weak rock. Structure is mainly pearly, vitreous and pearly. A bit foliated, na? You will have Flex, foliated means weak plants, okay, foliation in a particular direction. This will give the weakness of the perfect. So you will have a cleavage along a base, like your book, pages of the book. Well, one side you can easily take out the pages. Specific gravity 2.7 and 3.3. Okay, so hardness is less. That is why rock, if it's composed of mica only, okay, if you have less amount of mica, it's okay. But if the rock composed mainly of the mica, it's the major mineral mica, okay, so this will not give you a more strength. So you see these are the flakes, no? Hyalosilicate. So these are the flakes. So weak. Okay, this is muscovite, light in color. This is biotite, dark in color. So all are flakes. Okay. As a clay mineral, they are sheet silicate. Okay, sheet. So in which SiO4 layer are combined with potassium, magnesium, iron. So these are biotite. These are muscovite. They are light in color, mainly potassium and aluminum. Here you have iron and magnesium. Okay, magnesium and iron are there. That is why dark in color. These are because of the cleavage along the direction, they are broken into different sheets. Then clay minerals, they are the phyllosilicate, okay, like essentially very hydrous. The clay are important for to understand the soil. No, clay. We know clay. We discussed they are the mineral. If we sometimes call the clay soil. No, so we will discuss the clay mineral. They are hydrous aluminum silicate. No? They are common weathering product. We are having soil, very common in sedimentary rock. There are 4 groups: kaolin, okay, this is kaolinite, dictite, necrite, halloysite. So we don't go details about this. So there are 4 mainly clay. Kaolinite is 1, smectite is 1, there is montmorillonite, natronite, hectorite, illite is 1 group, and chlorite. So we can call it mainly generally. So what we discuss is that in clay, so we call it kaolinite. Okay, next we call montmorillonite is important, then illite and chlorite. These are the some of the clay mineral. So clay mineral, when you discuss something about the properties of the clay, you go for any of the civil engineering perspective to understand the clay, you have to understand the clay properties of the mineral. So they are triclinic and monoclinic, massive, different color, okay, cleavage is there, flakes are even, streak white, dull and earthy, that's it. Hardness is very less, 1 to 2.5. Specific gravity is low. Transparency, generally they are translucent. So secondary mineral formed by alteration of alkali feldspar. So this is important. That means the clay are the weather product of the other minerals. Suppose you have alkali feldspar orthoclase, na? Alkali feldspar, potassium, aluminum, silicate. If it is weathered, if altered because of the weathering, and this weather product will form a clay mineral. Okay, because of this clay mineral are the product of the alkali. So this all this clay, their property is depends on the parent rocks. So if you go to the Guwahati area during the, their clay are reddish in color and very sticky. And if you coming to this Upper Assam, this clay are not so much of sticky and red in color. So why? So this is important. So these are based on their parent materials. What is the parent material? What kind of mineral altered or weathered to form the clay? So it make a difference between the now in a rainy season, if you come to the Guwahati, if the water logging is there, after that if the whole of the roads are flooded with clay material, no? So they are very sticky, reddish in color. Okay, and in Upper Assam you will not get that type of things. Okay, So this is based on the, depends on the parent materials and the nature of the clay. Okay, they are used in different purpose. Okay, so our main component in the porcelain, okay, they sometimes in the ceramic industries. So yeah, I should time is over now. I should stop here.